Welcome to this video on normal distribution curve and the empirical rule. Well, first of all, distribution curve, much like a histogram, shows the probability of data in a sample space. Okay. Over here we have an example of a normal distribution curve. A couple of characteristics are the average or the mean would be the center. It's bell-shaped, which makes it symmetric. This also means you have more data in the middle than you do on the ends. Okay, the empirical rule for a normal distribution curve helps us break down certain probability or percents along the curve. So a couple of things to remember. The mean is in the middle, which is the average of all data. And a standard deviation talks about how spread out data is from the mean. So looking at this, each one of these little lines is a movement of a standard deviation in either direction from the mean. Okay? And the percents in between would be how much data is captured in that area. So in here there's 34% of the data, or you could say the probability is 0.34. This is an estimate. Much later on we'll get better numbers. But all this will add up to 100% because it's the whole curve. Here's an example of how to use the empirical rule. Test grades for the county have a normal distribution with a mean of 70 points and a standard deviation of 8 points. So given that information, we know the mean is the center of the curve, so the 70 is in the middle. And the standard deviation can be counted off in each direction. So here we would add a standard deviation to get 78. We'd add another standard deviation, which is 8 points, to get to 86. On the other side, we're subtracting. Okay. So you can interpret this as 34% of the students fall between 70 and 78 points. You can see that here. You can also say that 68% of the students fall between 62 and 78. You can get that by adding these two together. Another example is 47.5% of students fall between 70 and 86. So if you add these two together, you get the 47.5. Okay. And you can change these percents to probability. Just move your decimal. So instead of saying 34% of students, we could say there's a probability of 0.34 of landing between these two. You can also answer quantity questions if you know how many items you start with. Down here's an example. If you had 500 students and you knew that 34% of them fell in here, you could actually calculate that 34% of 500 is 170. So 170 students score between 70 and 78 points. Okay, a warning before we leave this. The empirical rule is only good when you can land on one of these splits that's already marked. Okay, so as an example here, if you tried to measure from 68, which would be about here, to 78, you can't break this up evenly on your own. Okay, all you have is for this total group here from 62 to 70. Okay, so you don't know how to break that up right now. Okay. As you can see, there's more here than there are over here. There's more closer to the mean than there is out, so you can't just break it up and divide it however you would feel. Okay, we'll learn that later. Thank you.